Alright guys, today we got geometric sequences and series. Yesterday we did arithmetic. Today we got geometric, just a little bit of difference. The difference is this. Yesterday with arithmetic we added the same number every time, we called it D. Today each number in the sequence can be found by multiplying the preceding term every time. Instead of by D, we're going to call it R for a common ratio. Common ratio is R. In this case it goes 2, 6, 18, 54. They're multiplying by 3. So our common ratio, or R, would be 3. So they're multiplying everything every each term this time to get the next term instead of adding the same thing every time. So the first kind of problem you're going to see is it's going to say for each of the following geometric sequences, identify the common ratio. Now the way you find the common ratio every time, the shortcut is you can put the second term over the first term. That will work every time for you. It gives me 2. And look what they're doing here. Multiply by 2, multiply by 2. Now, it doesn't have to be the second term over the first term. It could be the fourth over the third, the sixth over the fifth, as long as it's one later here over that one, or 12 over 6. So in part B, I would do -1/2 over 1. Anything over 1 as itself is just -1/2. You could probably figure that out by looking. So in part C, I would just say $3,900 or $5,200, and that's going to be 2/3. So there's your R is 2/3. So R is easy to find. Second term over the first term, or third term over the second term. The following term over the preceding term is probably the best way to say that. Okay, here's our formula for the day, and I'll show you where this comes from tomorrow. But to find the nth term, to find any term, you take the first term and you multiply by R to n-1 power. And remember what these letters stand for. AN is the term you're looking for. N is the number of terms. A1 is the first term. R is the common ratio. Make sure you get that down. That's the form. You're going to use that over and over today. Okay, the next problem says find the seventh term of that sequence. So I'm going to find the seventh term. I'm going to do the first term times R. If you can't tell by looking, R is 5. Remember, if you can't tell, you just do the second over the first, and that will give you 5. So I'm going to do 5. The exponent is going to be 7 minus 1, which is 6. So I'm just going to punch that in my calculator and see what I get. 4 times 5 to the 6th power, and I get 62,500. That's another thing about geometric sequences. They're going to go up really, really fast. Big numbers because they are you're multiplying instead of adding the same thing. So the next one says find the 10th term of this one. I'm going to need to find R first. Remember, R is the second term over the first term. If you reduce that, it's supposed to be 32. You get -1/2. There's my R. My first term is 64, so I'm going to have 64 times -1/2. Now, remember, it's n-1 power. I can't draw 2's today. It's supposed to be the n-1 power, so it's going to be the 9th power. And again, just going to take your calculator and punch that straight in. 64. Make sure you use parentheses here. -1/2 to the 10th to the 9th power, and change it to a fraction. Should be -1/8, and it is -1/8. All right, so pretty simple to use there. Make sure you got your calculator. That'll make it even more simple. All right, some of the first n terms, just like yesterday, we're following the same pattern as we did yesterday, just the formulas are different. And again, I'm not going to take the time on the video to show you where this formula came from. Probably show it in class 2 tomorrow. But the sum of the first n terms, however many you want, you do this right here. You take the first term, multiply that times 1 minus R. Don't forget R is a ratio to the nth power, not n-1 this time, but n over 1 minus R. Make sure you get that down. So the next slide or two, we're going to find some sums. Okay, so in this one, find the sum of the first 7 terms. We don't even know what the first 7 terms are. Don't even have to know to find that. So I'm going to say the sum of the first 7. Remember, following the formula is the first term times 1 minus R. R is the second over the first, which is 5, to the 7th power, the nth power, over 1 minus 5. Now, this is a doozy to punch in your calculator. I'll go ahead and warn you. You may want to break it up into pieces. You got to make sure that you have the parentheses in the correct order and things, and make sure you have, well, enough parentheses, because if you don't, it will really mess you up. So I'm punching all this in while I'm rambling right here, and I get this 58,593. And we'll take that first one in class tomorrow really slow and make sure we're really good on the calculator steps to punch that in. Let's do one. I think I got more. Yeah, find the sum. This doesn't look like it is geometric, but anytime it has an exponent like this, especially if it's k minus 1, but this is just a k, what you may want to do to make sure is if I plug a 1 in there, I get 0.3. If I plug a 2 in there, I get 0.09. If I plug a 3 in there, I get 0.027. So you can see what's happening. Bottom line is that's the r. The r is whatever's raised to the power. You find your first term by plugging in 1, and that's really all you need for the formula. Your n is going to be how many numbers, which is 1 to 11, which is 11. So I'm just going to go ahead and set it up. The sum of the first 11 is the first term, which is 0.3, 1 minus r, which is also 0.3, to the n power over 1 minus 0.3. And again, that's a monster to punch in, so be careful. What I'm doing on my calculator as I'm talking is I'm punching in the top of my numerator exactly like I see it, and hitting enter, and then I'm dividing it, opening a parentheses, and punching in my denominator. That way I make sure that I get it in right. And I got a big decimal, so I'm going to change it to a fraction and see what it says. It won't even change it for me. So, plus it was decimals anyway. I'm going to round this 0.4286. I'll tell you what might not be a bad idea. Stop the video, punch that in your calculator, make sure you get the same thing I just got. Okay, this is kind of strange, but it's really true. Believe it or not, you can sometimes find the sum of an infinite geometric series. Let that sink in a second. Infinite. That means it never stops. I'm so sorry. You can only do this if r, the common ratio, is somewhere between -1 and +1. It must be a fraction. You may see it written like this, like the absolute value is less than 1. If r is not less than 1, you cannot do this infinite one. I don't know I'll just show you this in class tomorrow why it is, but think about, well, let me show you this one. This is an infinite geometric sequence or series because I'm adding. This should be 32, and it keeps on going forever. Here's what happens. When I add these first two, I get 1.5. If I throw the 1/4 into it, I get 1 3/4. If I plug that in and add them up, I get 1 7/8. This one, you can see a pattern here, 1 15/16. This one, 1 31 32. And I keep on doing that forever. The problem is I'm never going to quite get to 2. What's happening though is I'm getting infinitely close to 2. Later we're going to learn that's called a limit. The limit is 2, and we're going to say that's the sum. Okay, so I get so close, I get infinitely close to 2. We're just going to say that the sum of an infinite series is 2, but it only works with fractions because that's what's causing me not to get all the way to 2, because I keep on adding a fraction. And I'll try to do a better job explaining that in class 2 tomorrow, but that's a pretty good one right there. All right, here's the formula if it's infinite and if it works. And remember, it only works if r is less than 1, the absolute value. And the formula is the most simple one of the day. It's just the first term over 1 minus r. Remember, first term r is common ratio, first term on top. So let's try 2 of these and we'll be done for the day. This one, you got, first of all, the directions say find the limit or sum if it exists. Find r first. Remember, r is second over first, which is 3. That's too big. It's not between -1 and +1, so it doesn't even exist. I'm going to put D, N, E for does not exist. The second one right here, part B, second over first, you get -1/2. There's the good R I can do it this time. So I'm going to say the sum of the infinite series is the first term over 1 minus 1/2. And again, I'm just going to punch that straight into my calculator. -2 basically divided by 1/2, and I get -4. Which means that sum is going to get closer and closer and closer to -4, but it's never going to get there. Infinitely close though, infinitely close. So we say the limit or the sum is -4. Okay, we can do one, that's helpful for one good thing, and that is this. We can use that formula for repeating decimals. So if I see a decimal like 0.78, 0.78, and the 7/8's repeating, you can break that down. You can write that like this. Okay, I wrote it as a sum, and it's a sum that goes on forever. If you put the second number in the sum over the first one to get your r and punch it in, you would get 0.01. So that's where that r came from. So to find out what the fraction would be, I'm going to do that formula. The sum of the infinite series is the first term over 1 minus r, which would be 0.78 over 0.99. So what I'm going to do is I'm going to punch that in my calculator and let it do the reducing work for me, because it's good at that and it's fast. And it gives me 26 over 33. And I guarantee if you punch in 26 divided by 33 in your calculator, it's going to go 0.78787878, and eventually round it up to 9 probably, because your calculator screen does not go infinitely. So anyway, hope that wasn't too bad. Quite a bit of stuff though. We'll go over it in class tomorrow like we always do. Look forward to seeing you. See you, bye.